Assalamualaikum warahmatullahi wabarakatuh. My name is Azri Nazira binti Azali. So I will explain about the analysis of acrylamide in food products using Hplc. Acrylamide is an organic compound with the chemical formula CH2 double bond CHC ONH2. It is a white orderly solid that's soluble in water and several organic solvents. Hplc or high performance liquid chromatography is a process of separating components in a liquid mixture. In figure 1 shows a basic overview of the Hplc process. The solvent used to separate components in a liquid sample for Hplc analysis is called the mobile phase. The mobile phase is delivered to a separation column, otherwise known as stationary phase, and then to the detector at a stable flow rate controlled by the solvent delivery pump. A certain amount of sample is injected into the column and the compounds contained in the sample are separated. The compounds separated in the column are detected by a detector downstream of the column, and each compound is identified and quantified. In the column, the stronger the interaction between the component and the mobile phase, the faster the component moves through the column along with the mobile phase. On the other hand, the stronger the interaction with the stationary phase, the slower it moves through the column.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Jamiti Muhammad Ramadan and I will continue with methodology. The first one is for the food sample. There are 43 samples of food that has been tested, and 16 of them is a French fries from various local restaurants. 13 is branded biscuit from local shop, and 14 samples are biscuit from the local bakery shop at Piyaj Raj. The next is standard solution. The stock solution of 1000 ppm acrylamide were prepared and then dilute with ultra pure water to give a several standard 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100 ppm solution. All of the solution were processed at 4 degrees Celsius for around 3 months. And Paris one solution was made by dissolving 15 grams of potassium hexacyanoferrate into 100 milliliters of distilled water. And to create the Paris 2 solution, 30 grams of zinc sulfate was dissolved in 100 milligram of 100 milliliters of distilled water. The next one is sample preparation. 1 gram of the fat sample was placed in 15 ml centrifuge tube, and then the water 10 ml of water then was added. The tube was then centrifuged at 10 degrees Celsius for 10 minutes at 10,000 rpm. The feed rate was transferred into another centrifuge tube, and then the Paris 1 and Paris 2 solution was added into the solution. Both are 0.5 milliliter. And then it has been mixed, and then again centrifuged at 10 degrees Celsius, 10,000 rpm for 10 minutes. As a result, the supernatant was removed and evaporated in the water bath for 40 degrees Celsius for 15 minutes and filter with 0.4 micrometer cellulose acetate shrink filter paper. And then for HPLC DAD condition, anisocratic elution was utilized to separate the analyte with water and acetonitrile ratio of 90, 10, 90, and 10 functioning as a mobile phase. And then the reverse Zorback column method used a flow rate of 1 ml per minute with a temperature of 40 degrees Celsius and at 210 nanometer wavelength detection by injecting a 20 microliter volume of solution. The entire runtime for acrylamide was 50 minutes with a retention time of 0.463 minutes.
For the analysis, the detection and quantification of acrylamide DDAD diet error detection detector was used in Hplc. The linear calibration curve of 10 concentration levels with a regression coefficient is 0.99973 and the peak area is correlated to the acrylamide concentration linearly. In the table, it shows the value of LOD and LOQ are 3.733 and 11.045 respectively. Furthermore, the recovery percent were carried out by applying 10 non-amounts of standard acrylamide to the blend water sample and run in Hplc. The recovery range is 98% to 110% with correction value less than 10%. Using the above method for Hplc quantifications, samples were extracted and all show clear chromatogram peak at their retention time. Graph shows the chromatogram peak of acrylamide in standard and samples. The difference between the processing conditions and chemical composition of the raw material was applied, which may be the cause of the variance in the acrylamide content between the various batches of a product category. For the graph in A, the rotation time for acrylamide standard is 0.464, and for graph B, the rotation time acrylamide with the sample bakery biscuits is 0.481. For the graph C, the rotation time of acrylamide in the sample French fries is 0.377, and the last one, the graph D, the rotation time of acrylamide with the branded biscuit is 0.472.
For the third table, this is a table for acrylamide content in the French fries, brand biscuit, and bakery biscuit. The data F1 until F16 is for French fries, H1 until H13 is for branded biscuit, and A1 until A14 is for bakery biscuit. European Commission has recommended a value of 500 microgram per kilogram as benchmark level for biscuit. But when we see the table, there are 38% branded biscuit and 64.1% of bakery biscuit have a acrylamide content above the benchmark level. In branded and bakery category, 50% and 7% sample from the sample were above the indicative value. Altogether, 62% biscuit in branded and 36% sample from bakery section were having acrylamide within acceptable range, and rest were high. The indicative value and benchmark level of French fries are 600 microgram per kilogram and 500 microgram per kilogram respectively. But all of the sample, which means 100% of French fries, shows a concentration above the indicated value as well as benchmark value. The maximum value of acrylamide was found in the sample of F6 and also F16 sample of the French fries is at the maximum level. Acrylamide has been characterized as an increased cancer risk for human, and based on previous studies, HMF was found that harm human health lead to cytotoxicity to mucous membrane skin and high respiratory system. Report of mutagenesis, chromosome abnormalities, human and animal carcinogenicity have also been reported due to acrylamide toxicity. That's all from me. Thank you.
So in this video, I will explain about the conclusion. In conclusion, Hplc, or we call it as high performance liquid chromatography, can be used to identify each compound, separate the component of a compound, and determine how much of each component is present in the mixture. In the field of quality control of drug components, it is the fastest, safest, and most adaptable method for chromatography analysis. When analyze material for a wide variety of organic compounds, Hplc is the method of choice. There are also several pumps used in Hplc, which are reciprocating pump, screw-driven shrink pump, and also pneumatic pump. One of the most vital parts of Hplc system is the infusion pump. According to the factors of a constant output liquid, infusion pumps are divided into constant pressure pump and also constant flow pumps. Based on article, acrylamide was measured using a quality addition method in sample of heat processed food. Besides, the study's findings demonstrate that fried and baked food products frequently contain significant amount of acrylamide, especially in the country of India.